This video is about finding the least common denominator, which we need to do by finding the least common multiple. So we are going to start by just taking some basic numbers and finding the least common multiple among the sets of numbers. So let's say we have 4, 16, and 27. The way that it'll work every time is to do what's called prime factorization. So breaking the number down into what the prime numbers are that are like the square roots or the cube roots of the problem. So the way that I do that is I break it down into its factors. So 4 could be 4 times 1, but that doesn't help us. It could also be 2 times 2, and there we go. That's its prime number, right? So 2 squared is that prime factorization of 4. 16 I can break down into, it doesn't really matter how you start breaking it down because you'll finish it the same way. Let's say we break it down into 8 and 2. 8 can break down into 4 and 2. 4 can break down into 2 and 2. So this is, 16 is broken down into 4 2. So 16 is 2 to the 4th. 27 I can break down into 9 and 3. 3 can't be broken down anymore because that's a prime number. 9 I can break down into 3 and 3. Okay, so that's it. I can't break it down anymore. So that'll be 3 to the 3rd. Okay, so when I'm doing, so now I've got all these numbers broken down into their prime factorizations. So when I'm finding the least common multiple, anytime there's the same base, I just would take the bigger exponent. And then anytime there's a different base, I just have to take whatever is there. So these 2 squared and 2 to the 4th have the same base. So for my least common multiple, I'm going to take the bigger one. So 2 to the 4th times 3 to the 3rd. That's going to be the least common multiple between 4, 16, and 27. If you were just looking at the least common multiple between 4 and 16, it makes sense that it's 2 to the 4th because 4 is a factor of 16. So 16 would be the least common multiple between itself and 4. 27, though, breaks down into 3 to the 3rd. So for the least common multiple, you have to multiply that on to the 16. We'll do another one. So 2, 3, 6, and 8. So 2 just is itself, just 2 to the 1st. 3 is just itself, 3 to the 1st. 6 we can break down into 2 times 3, so that's 2 to the 1st times 3 to the 1st. And then 8 breaks down into 2 and 4, and then the 4 breaks down into 2 and 2. So we have 2 to the 1st, 3 to the 1st, 2 to the 1st, 3 to the 1st, and then 2 to the 3rd. So what do I have? Well, when I have the same base, we talked about this with 2 squared and 2 to the 4th. When I have the same base here, 2 to the 1st and 2 to the 3rd, I have to go with 2 to the 3rd, right? Same with this 2 to the 1st, 2 to the 1st. I have to pick 2 to the 3rd as my least common multiple. I have to pick the biggest exponent that's in that base. Okay, and then I will also have to multiply on a 3 to the 1st. So the least common multiple between all 4 of these numbers is 2 to the 3rd times 3 to the 1st. Okay, and if you're multiplying it along at home, you know that's going to be 2 times 2 times 2 is 8 times 3 or 24. So 24 will be the least common multiple between all of these. So that's how a fail-safe way to find the least common multiple every time for numbers. But the reason we need to do it and the reason why it's so important to us now is because we're looking at solving rational equations by finding the least common denominator, which is basically just finding the least common multiple. So we'll do a couple examples. You'll try a few and we'll look at the answers to them. But this video is really to help you try to find the least common denominator. So let's look at example 1, again, thinking about the way we did it in those first 2 examples. So our denominators are 6, 3, and 2. Okay, so 6, 3, and 2. If I were to break 6 down, it breaks down into 2 and 3. 3 doesn't break it down into anything, and 2 doesn't break down into anything. Okay, so the least common multiple would be 2 to the 1 times 3 to the 1, or 6. So our LCM here is, or our LCD, least common denominator, which is the least common multiple of the denominators, and I'll just be consistent. I'll just write LCD is going to be 6. Okay. So I'd like for you guys to try this one. X over 5, X over 2, X over 1. What's the LCD? Okay, so pause the video, give it a try. All right, so we realize when we do it that 5 is a prime number and 2 is a prime number. So when we break 5, 2, and 1 down, 5 breaks down into 5 to the 1, 2 to the 1, 1 to the 1. So 5 times 2 times 1 is just 10. Okay, let's try it with some variables now. So here we've got a true rational expression with variables in the denominator here. So we have 4 over x, 3 over y to the third, and then 1 over xy squared. So least common denominator, we're looking just at the denominators. All right, so x is just x to the 1. Okay, y has an exponent of 3, and then here we have x times y squared. Okay, so the biggest exponent I have that's attached to x is just 1. So my LCD is going to include an x to the 1, right? And then if I look at my y's, the biggest exponent that I have that's attached to my y's is a 3. So that'll be y to the 3. So my LCD will be x times y to the 3, to the third power. And now you all can give this one a try. Just pause the video, give it a try. Okay, and when we're done, our LCD is x squared, y squared, right? Biggest exponent is 2, because this one's only 1, and then the biggest exponent for y is 2. So x squared, y squared is our least common denominator. Okay, let's roll to another example. So now we have a little slightly more complex problem because we have to factor. X squared minus 1 is in fact factorable. That's our wonderful difference of perfect squares. So I factor that as x plus 1, x plus 1, x minus 1. My brain is not matching my body today. X plus 1, x minus 1, okay? And if I break these down, this is x plus 1, x minus 1, x plus 1, x minus 1. Right? So I always have to take what is multiplied together, because this is isolated. So my LCD is just going to be multiplied together, x plus 1, x minus 1, and that's the best I can do for that one. Okay, so give this one a whirl. It's very similar. Pause the video, give it a try. And we get, when we factor x squared minus 4, it's x plus 2, x minus 2. So that is in fact the LCD, right? Because just like with the prime factors, when we break them down, we have to go with, you know, the other one that has them multiplied together, which is this, x plus 2, x minus 2. Okay, example 4 is very similar. So we've got 2 over x squared plus x plus 5, 1 over x plus 5, 1 over x plus 1. So again, we have to factor. This is not a special case. It's not difference of perfect squares like these two were. If you need a little review on the factoring, right? This is your A is 1, your B is 6, your C is 5. What multiplies to 5 and adds to 6? It would be 5 and 1. So our factorization is x plus 5 times x plus 1. Doesn't really matter what order you put them in. So now that we've broken this down, we see that just like with example 3, our least common multiple is these two multiplied together. So x plus 1 times x plus 5. That has to be our LCM or LCD. Okay. Pause the video, give this one a try. And here we are. Factorization. These and these both multiply into that. So our LCD is x minus 3 times x minus 1. Okay, just as a little bit of additional practice, if you would like, find the LCM of these sets of numbers and variables and terms. Go ahead and pause the video, and then you can check your work in a bit. Okay, so LCM here must be 18. LCM here must be 20. LCM here must be 6xy. Okay. All right, I hope that helped. Remember that breaking down your terms into the prime factors is always a helpful thing to do so that you can see what they are. Let me know if you all have any questions, and I'll see you next time.